6 from our shadow generated paper, we have a circle with center 5 minus 2 and a tangent of 3x minus 11, which touches at point Q. Show that BQ, B being the center of the circle, has this equation. Well, there's many ways that you might want to answer, but probably the easiest one is to notice that if m is 3 for this one here, then the gradient of the radius will be minus a third. Okay, because a tangent and a radius are perpendicular to one another. So that sort of tells me something about this line here. Now, if I wanted to do a bit more, I need to use a coordinate with it. Well, I could use the center of the circle. So our solution looks like we can use this with the center of the circle was 5 minus 2. So let's use y minus y1 equals m x minus x1. So we're going to do y minus 2, so y plus 2 equals minus a third x minus 5. A nice trick here would be to multiply everything by 3. So that would give us 3y. That's a plus 2, so plus 6 equals minus a third will become a minus. And these stay the same because it was already taken care of when you did that part there. So let's simplify to finish now. What's the goal? The goal is x plus 3y. So let's do minus x plus 5. Let's bring this to the same side. So x plus 3y. I think we've basically done it, haven't we? So x plus 3y equals minus 1 because the 5 minus 6. Yeah, okay, great. So we've done that one there. Next, find an equation of the circle in this format. So that's the coordinate at the center that we already knew about. What we really need to do then is be finding the radius, don't we? So what's the best way to do this? Well, seeing as we just did some stuff with this line and we already have this line, why don't we talk about these lines crossing each other, solving them simultaneously, and then a bit of Pythagoras to find that one there. That might be the best way to do it. So we've got x plus 3y. Right, we've actually got these equations already, haven't we, to solve with one another. So we're going to solve these two equal to each other. So for part B, let's jump into that. So x plus 3, this is what I'm going to sub in, so I'll leave myself some space. 3y equals minus 1. And y is now 3x minus 11. So x plus 9x minus 33 equals minus 1. 10x then equals, is that 32, I believe? So x equals 3.2. When we find out that x equals 3.2, we can sub into maybe that equation there at the top. So y equals, what's that? That's 3 lots of 3.2 minus 11, which comes out to minus 7/5, which is what? That's the same as minus 1.4. Okay, why were we doing all of that? So we were doing all of that so that we know this point here. So if I just sketch out my triangle here. So this is from minus 1.4 to minus 1.4 to, hang on, sorry, 3.2 to 5. So I think there I've got that one there is 1.8. So that's going to be a 1.8. It's at minus 1.4 and it was going down to minus 2. So that's a 0.6. So if I do 1.8 squared plus 0.6 squared and square root it, that would be how I would get the radius. Okay, and the radius is root of 18 over 5. Because for the formula we actually use r squared is just 18 over 5. So that's what I would put in there. Okay, so let's write it out. So x minus 5 squared plus y plus 2 squared equals 18 over 5. Okay, so that's 3.6. So the square root of 3.6, yeah, that seems sort of about right. That sounds reasonable. Okay, that's what we've done so far. Now, final part. So let's clean up our diagram. Final part. Another line with a gradient of 3, right, where it's not a minus 11 is also a tangent. Well, I think we draw this one on to start with. So something like this for part C, yeah? Find the value of K. So find what that y-intercept would be of that one there. Now, there's all kinds of ways that you can solve this one. Let's try a discriminant approach. So the discriminant says that when you have tangents, that you should have a discriminant of 0. So what we're going to do first is we're going to use the circle with this y equals 3x plus k. So if we did that, we would get, so I'm going to start with this one. I'm going to start expanding this out. So I'd get x squared minus 10x plus 25. The y bit. Okay, so if I did the y bit, I would get, is this the nicest way to do it? Well, we've started, so we might as well carry on. So this would give us, what was that? 3x plus k plus 2. That would give us that squared, and then that would equal 18 over 5. So this is one way that we could do it. If we simplify this one here, and if we use the discriminant, so b squared minus 4ac equals 0, that will be a legitimate way, but I think that I'm just a little bit concerned about how nice this will be. So I think I'm going to use a different approach instead. I think I'm going to use some symmetry to this. So we already know what this point is, don't we? So this point, what was this? This was minus 1.4, and this was, beg your pardon, that was 3.2 and minus 1.4. So I've sort of staircased down like that. Now, because I have the same situation, these are parallel lines on the other one, I should find that I'm able to do the same thing over here. So this was 5, so I'm going to do 5 plus, in fact, it's these numbers, isn't it, from before? Do you see these ones here? So I'm going to do 5 plus 1.8 to get the x part of that value. And then I'm going to do, over here, I'm going to do minus 2, and then I'm going to go down another 0.6. So I think I feel quite confident to say that a point on the line would be 6.8 and minus 2.6. And I'm going to use that with what? I'm going to use that one with m as 3, because I think that's what I was told, isn't it? Yeah? So let's try substituting that in now, because I think it will be a vastly superior way than this one. There are all kinds of ways to do this one, but I think this is the way that makes the most sense in my opinion. So y minus 2.6 equals 3, and then this is going to be x minus 6.8. So if we do y plus 2.6 equals 3x, shall we do this one here as well? So what's that? 3 times 6.8. So that's minus 20.4. And then look, we can just add that to the other side. So y equals 3x minus 23. So I think my k value there is minus 23. So that's one way that you could have answered that question there. I think having the diagram so you can sort of see what's going on makes that much, much easier. So that's question number 6 from our shadow paper.